In 1909, Robert Millikan, working at the University of Chicago, succeeded in measuring the charge on the electron. He allowed a fine spray of oil to settle through a hole into a chamber where he could observe their fall. The top and bottom of the chamber consisted of electrically charged plates. He introduced a source of X-rays which can cause creation of charges when they strike matter. Charges produced by the X-rays attach to an oil droplet, producing one or more charges on the droplet. When there is no voltage applied, the fall of the droplets is determined by their mass and the viscosity of air through which they fall. When a voltage is applied, the droplets that have a negative charge will fall more slowly, stop falling, or even rise, depending on the number of charges on them. By adjusting the applied voltage and observing the droplets both with voltage off and voltage on, Millikan was able to determine that the charges on the droplets were all multiples of a smallest value, 1.6 times 10 to the minus 19th coulombs. He took this to be the charge on a single electron.
Le modèle atomique de Thomson. En 1897, un scientifique du nom de J.J. Thomson émit l'hypothèse que les atomes étaient formés de particules encore plus petites. Au cours de l'une de ses expériences, Thomson fit passer un courant électrique à travers un tube duquel on avait retiré presque tout l'air. On observa alors un faisceau lumineux créé par les particules qui traversent le tube. Thomson observa qu'en approchant un aimant du tube, il pouvait faire dévier le faisceau. Il conclut alors que les particules devaient avoir une charge. Il leur attribua une charge négative et les nomma électrons. Thomson émit aussi l'hypothèse que les atomes devaient contenir des charges positives car les atomes étaient neutres dans leur ensemble. Son modèle de l'atome se présente comme étant une matière positive dans laquelle sont dispersées des particules négatives. On lui donna le nom du modèle du gâteau au raisin. Il imaginait qu'à la façon des raisins dans un gâteau, les électrons étaient dispersés dans l'atome de la même façon.
In 1910, Rutherford and his co-workers were studying the angles at which alpha particles were scattered as they passed through a thin gold foil. Most of the alpha particles passed through undeflected. However, a few were found to be scattered at large angles, some even back in the direction from which they had come. This meant that they had collided with an object much more massive than the alpha particles themselves, yet so small that only a few alpha particles encountered them. This atomic level view shows what is happening. Most of the atom is occupied by the low mass electrons. The nucleus is small and massive. When an alpha particle encounters a nucleus, it is scattered at a large angle.